Hi, Emily.
Hey, Mike.
How's it going?
It's going well. How is it going for you?
Yeah, not too bad. Not too bad. So let me introduce us. My name's Mike Dockery. I'm a former corporate M&A partner at Morrison Forrester, and now I am the Director of Product and Chief Legal Officer at Marveri. You are Emily Mu. You are a former PhD candidate in machine learning and AI at MIT, which you left to then become the co-founder and Chief Technology Officer at Marveri. So thanks for joining me today. I should mention we are presented by our company, Marveri. Marveri is an AI-powered platform that provides an easy and efficient way for corporate lawyers to quickly understand like a large group of documents. And we could talk more about that in a bit. But for now, today, we are going to talk about context windows.
That sounds good to me.
Excellent. So kind of just to give the backstory, the reason we wanted to talk about context windows is, I mean, this almost goes without saying at this point, but there's been a lot of recent model releases. And one feature that we sort of noticed about these model releases is they are having ever increasing sizes of context windows. So like Gemini 2.5 Pro is 1 million tokens, says it's going to 2 million soon, whatever that means. The GPT 4.1 family came out. It's also got 1 million tokens across the family. And then Llama 4 actually had just an incredible 10 million token model with Scout. And then even their sort of mid-size or mid-range model has 1 million tokens, I believe. So we're just seeing this sort of trend of like context windows get longer and longer, and thought it'd be good to talk about it. So what are the implications of that? But before we get into all of that, like I think we should just level set on like the basic vocabulary. So let's just talk about for what are we even talking about when we say context window? I mean, I know the sort of very obvious non-technical answer is it's like the word count for your chatbot box, but there's a lot more to it than that, right?
Yeah, absolutely. I mean, I think the first question is why is there a limit? And maybe to kind of, I know we have a pretty non-technical audience, but maybe to kind of take it back down to the basics. Effectively, how machine learning language models work is that they take language, we convert it into numbers or some numerical vector type representation, and then the goal of these models is effectively to just learn patterns across sort of the numbers that has been converted into. And for the mainstream models that everyone kind of uses nowadays are called transformer models. And transformers are encoder decoder models. So you turn them into numbers and then you turn them back into language. And so how transformers are trained are by using this concept called self-attention, which effectively kind of defines how tokens relate to each other across a certain size, which is what we call actually a context window. And so this allows for this sort of long range interaction between tokens. And if you think about it, that's actually really kind of crazy, right? Because a 10 million size context window means that we're training models with sequences of length 10 million or a maximum size of 10 million, and we're learning these interactions between all of these sorts of tokens. And that's part of what has actually made transformers so effective in such a way. So context windows are also, it's not the reason, it's not just sort of the amount of language that we can sort of put into the model, but it's the amount as well that's sort of defined by the interactions that we're learning during training.
Yeah, so I have a couple of questions there, but before we get to that, maybe we should take a step back even further. Like, what do we mean when we say a token?
Yeah, no, that's a great question. So tokens are effectively, and you can think about this as sort of like parts of words. They can also include things like punctuation, and they're meant to be lexicographical. And so on average, there's around 0.75 tokens per word. And you can almost think about this as sort of broken down pieces of words. So if you've ever studied etymologies, you can break things down into words, into parts. Like, for example, unbelievable can be broken down into un, which sort of means against, believe, obviously sort of the core of the word, and able, sort of this ending type punctuation, or this ending type etymology. And so so I think this next question is, why do we want to use tokens and not just use words directly?
Yeah.
And the reason why we want to do that is because it allows us to handle sort of this more complex language. Like the un from unbelievable can be reused for many other words as well, such as uncommon or.
So the model can sort of learn to relate that little piece of that word to every other word in the training set.
Precisely, and it gives you a lot more flexibility, allows you to infer meanings of new words. If you've ever taken the SATs, that's probably very common. You learn sort of these etymologies to be able to understand sort of a higher vocabulary, and the models do so as well.
Okay, yeah, that makes a lot of sense. So, I mean, maybe let's just put it into context. Like when you say a model, let's just take the average. There's higher and lower, but a million contexts or a million token context window. Like, just to give some concrete examples, like what are some examples of like works that people would know that would fit into a million tokens?
Yeah, that's a great question. So both the Old and New Testaments combined together is around 1 million tokens. For those who are coding inclined, the scikit-learn repo has around 2 million tokens. So a million tokens, 2 million tokens are actually quite a lot of tokens, quite a lot of context to be able to provide. Les Miserables by Victor Hugo has around 800,000 tokens. War and Peace is around the same size, also around 800,000 tokens. The list kind of goes on, but that's quite a lot. You could send that all in a single query.
It's an enormous amount of text, right? Like I think I saw somewhere this would be like on average something like 150 Supreme Court opinions, dozens and dozens of like medium length commercial contracts. You can fit an enormous amount of text into these huge context windows, which obviously that opens up a lot of implications, I think. I did want to ask you though, so just because these models have this sort of stated context window length, I gather that doesn't necessarily mean they will all perform the same across that context. Is that right?
Yeah, exactly. In fact, sort of one of the problems of having such large context windows is that, kind of how we talked about in the very beginning, when you do training, you're learning sort of relationships across this entire context window. And once you start getting to really high context windows, kind of just as we described, there's not that many works that are quite that long. And so learning sort of those relationships becomes much more difficult when you don't have examples or training data or a lot of training data that have sort of these relationships across such large expanses of natural language. And I think also kind of on that same point, there's been a lot of research done as well, sort of even early on prior to context windows getting so huge, that oftentimes as you expand the number of tokens that you can accept in your context window, there's also sort of this like needle in the haystack problem, right? Like if you're looking for anything very specific, so actually just expanding the amount of context window doesn't guarantee that you're going to find what you're looking for, because there's so much information. And relationships are harder to learn.
Yeah, and that kind of actually gets to another point I wanted to ask you about, which is really going into this Gemini point. I've been very vocal about how cool Gemini 2.5 Pro is, but up until sort of that model, it felt like Google was really falling behind. Like OpenAI and Claude, Anthropic, really seem to be outdoing them on this LLM front. And I have heard recently some speculation that maybe that would have been because they were focused on these huge content. They've always had a really big context window for their models. Maybe because they were sort of trying to get big context windows so they could integrate search, that sort of thing. So, I mean, I guess the first question is just like, does that make sense as an explanation? Like, would focusing on large context windows early have sort of led them to be behind in the development?
I mean, I think that's definitely possible. I guess maybe to kind of set, and I'm sure you're aware of this history already, but to kind of ground the conversation, Google has always been at the forefront of sort of a lot of large language model research. And just to give an understanding of just how fast things are growing, right? Like BERT, which was published in 2018, which is actually not so long ago, has
Feels like ages, but yeah.
it feels like ages, but it only had a context window of 512 tokens, and everyone thought that it was so novel and so crazy. And I think kind of just to give a sense of why training longer context windows is so expensive. I'm sure if you've been playing around with OpenAI models, the longer, like every token, you have to pay more money. The larger models, the longer context, the more complex the model, the more money you have to pay. But when you're training sort of these super long, like why can't you just have an infinite size context window? And sort of the answer to that question is because we're learning these long range interactions. It pretty much sort of scales quadratically in terms of the amount of compute that you need in order to train on sort of the length of the context window that you have. And so if you double your context window, that kind of roughly equals to 4x the amount of compute you would need to be able to train a model on that data. And so if Google is focusing on sort of these very long context windows, their abilities to sort of like train these models, the compute resources needed in order to even sort of do that process, the cost, like the financial cost of that grows quite a bit.
Yeah, I can't remember what. So there was Bard before there was Gemini. I can't remember what Bard's context window was, but I know like even since sort of the first iteration of Gemini, it's been like a million. I think it's been much longer than everybody else, but it didn't really perform across that window. So they it seems like Google has been behind. I do wonder though, like if the trend is going to be towards larger and larger context windows, I do wonder if their sort of head start there may be like a really big advantage for them going forward. I have seen some benchmarks, even with the latest like GPT 4.1 family. They have a million token context window, but they don't really seem to be performing across that window very well. Whereas I think, well, the benchmarks I've seen at least suggest that the Gemini is really performing across that million tokens. So, yeah, it may be that becomes a real competitive advantage, I think.
Yeah, no, absolutely. I mean, the longer the context window, the better you can learn those interactions, the more of a competitive edge that you have. I think it really honestly boils a lot down to sort of what data are you training on? What are the sort of clever model techniques that you're using to sort of capture those interactions? How well can you, and then that sort of leads to how well you can perform on benchmarks down the line. It's the race is honestly so fast. It's very hard to sort of predict a lead horse. I think that people are kind of coming at it in different ways. Honestly, I think even OpenAI, like rather than coming at it from a context window standpoint, it feels, at least to me, that they're coming at it from a multimodality standpoint. Right? They're like they have a lot of audio models, visual models. They were sort of the first to sort of put forward Sora. That's a ton of data in some way, but it's different modality, than language. So it's kind of interesting to kind of watch and see.
Yeah, and I mean, I guess that's another question I wanted to ask you about. Like, it seems like the reasoning models are sort of lagging here. They don't have. I think O3 and O4 Mini are still at 200,000. I think. Is there a reason for that? Like, are they just saving back tokens for their reasoning chains, or is there something else in the way that those models are operated that would cause them to sort of lag there?
Yeah, I mean, this is only my hypothesis. Reasoning models definitely take longer to train. because you're evaluating not just sort of the output result, but also sort of like the intermediate steps for that, right? It takes longer to produce results too, if you've ever used so the inference component also takes longer, the training components take longer. I assume like they haven't released their models, but I assume the models themselves are more complex as well. And so given that the training cost is sort of proportional as well, not just to the context window, but also to how fast can you use, like how fast can you produce results, how fast does the training loop take. That is a ton of of, 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 of cost as well. So that's my hypothesis for why it's not quite as long as sort of these straightforward one-shot models. But I think they are improving across all fronts. 200,000 even a year ago would have been
Yeah, it
crazy
would have been
to say.
massive. I mean, I can remember like I think when we first started working together, it was like 8,000 was the biggest. Like,
Yeah,
and that felt like a lot at the time. But yeah, so I'm not trying to rip on them for 200,000. That is it's a lot of text, but it does feel like they're growing. Um, I guess that also points to, so obviously the recent big announcement from Meta, Llama 4, the Llama 4 family includes Scout, which has 10 million tokens, which is just, I mean, you know, all those examples that we cited earlier of works that are a million like you could just do all of those all at once. I have seen a little bit of discussions suggesting, I mean, I don't personally have the $200,000 worth of GPUs that it would take to run Scout, but I have seen some people suggesting that it's kind of crap across that large context window, which makes you question, right, like what it's even the point. But yeah, like I I have always been thinking that, especially in the field that we're working in law and other sort of highly regulated industries, right, where confidentiality is paramount. I have always been wondering, like, whether there was ever going to be this, whether the eyes were going to turn towards local models as a means to sort of, you know, firewall your data. Um, but it's enormously expensive, right, to run these models.
yeah, no, absolutely. It's hugely. I actually remember I tried to download and utilize Llama 7 billion, which was their 7 billion parameter model, 2 years ago, on my local machine, and it pretty much crashed everything else.
Yeah.
These models are huge. When they say that you can, like, I think the open source community is definitely super powerful. It's super interesting to kind of see the open source community catch up. I know DeepSeek is a whole nother discussion, but in my personal opinion, I think that it's inevitable that the open source community will catch up, no matter sort of how many guardrails or like how many engineers that OpenAI recruits. That being said, I do think that there is sort of this barrier to entry in terms of just how expensive it is to run these models. Like even running an image model, I remember reading the other day, it was like it's like the same amount of just like natural resources as just like like creating a bottle of water, things like that. So the queries are like hugely expensive in terms of electricity. And just to give you also kind of a more concrete and sort of funny example, so Stata, the MIT building that CCEL was built in, when they built that data center, they weren't anticipating the level of electricity that now that all these AI researchers, and we're not even building like the new OpenAI, like mostly, like we're maybe running inference, right? But like the building was not, has now sort of not been able to support the electricity requirement to run all these servers. And so they had to create a new server farm somewhere else. So that kind of gives you, I guess, a thought of just like how much power it takes. And then
Yeah, I have to imagine that MIT has some pretty sophisticated power engineers over there. So to outrun their capacity is pretty impressive. But yeah, I mean, you know, you've got these companies talking about building just unimaginably huge data farms, right? Like all over the place. Um, they're just so power hungry. I've actually seen some people talking about like the effect that some of these data farms are going to have, it's normally like it's a very straightforward conversation, right? Like this company wants to come in and build this massive facility and create all these jobs. It's great, like welcome them in, give them tax breaks or whatever. But actually, communities are having to sort of do that cost benefit analysis of, wait a minute, this may literally crash our power grid.
Yeah, it's insane. And I think honestly, even for our industry that we work in, I know confidentiality is super important. I think it really kind of contextualizes on-prem solutions, right? Like there's very little. I think it's a low probability that law firms, no matter how high tech, will deploy their own versions of complete models. I think more likely it'll be sort of these data retention policies, going through very trusted providers, things like that, and sort of doing a plug and play rather than trying to host or provide service to models themselves. It's just unfathomable to think about from that latter perspective.
Yeah, and then I mean to our topic, right? Like as the context windows grow, I would assume that just increases the load even more.
Yeah, absolutely. Even for inference, which is insane. So, yeah.
Yeah. Well, so I mean, since you mentioned it, let's just sort of talk about what we're seeing these super long context windows grow and grow and grow. I mean, I have my perspective. I think for legal, it's just going to allow, a lot more inference over a lot more documents. I mean, there's virtually no legal document in the world that will not fit within a million tokens, right?
Yeah.
And I mean, I know that there are techniques out there that maybe we'll talk about more at a later time, like RAG, which allow you to sort of cram more information in. But those aren't ideal. And so to me, it just seems really straightforward. Like more context is better for legal.
I think generally that is the case. I will say, kind of this ties back to an earlier aspect of our conversation. It really depends on how well those models can understand the interactions across these large context windows, right? So what I mean by that is, like, if you could dump a whole data room into Llama Scout 4, but if it can't really tie together information across like your first document to your 400th document to your 4000th document, then it's not really useful, particularly for the context and for really complex and really detailed workflows. And I've learned over the last few years that lawyers are very detailed, and those details matter a lot. And so I really think that in general, I agree with the statement that longer context windows do give you a lot more flexibility and don't make you rely on techniques such as RAG, which has its own problems that I have a lot of thoughts on RAG, from just implementing it myself to reading about it a lot. It's an area that I'm really interested in. But I think even kind of beyond that, it's how well can you really understand sort of these relationships, and not just the relationships, but the problems that you're tackling, right? And so I think that actually matters maybe more, or at least equally, to the context window point.
Yeah, and then I mean, just to take it to your side of the building, which honestly, like coding and legal are probably more like than most people know. But like I know that your team has been experimenting, or I think actually using now Cursor. How does like that longer context window facilitate using these models for coding? Is it a huge advantage?
Yeah, no, that's a great question. So I've used Cursor personally quite a lot. Our team uses Cursor. I also have recently been using Claude Code, which is known to be one sort of the best, most novel sort of ones. Uses 3.7 thinking on the background, and also has this sort of agentic workflow. I will say, I think generally it does give you a lot more flexibility in terms of just like really and especially Claude Code in comparison to Cursor, identifying places across documents where things need to be changed for functionality. That being said, to just give you a very concrete example, you still need to know how to code, frankly.
Yeah.
And sort of an example of that is I was developing a feature using Claude Code sort of the other day. It wasn't super complex, but it was with the part of the code base that I'm a little less familiar with. I'm more familiar with sort of the AI components, less familiar with sort of the front end server side code. It took me 86 commits across 3 to 4 days. And that's like, oh, like try doing this, and then, oh, actually go back, right? Like that was not right. Um, and that's from someone who understands when it wasn't functioning properly. So I would say it's not so, I feel whenever I read a LinkedIn post and someone's like, oh, like you can create a whole enterprise scale system now using these systems, they've never built an enterprise scale system. I guess I'm very pro using coding tools, maybe to give you a sense of that. I think that it kind of takes you maybe 80 to 90% of the way there, but without that last 10%, nothing's going to run, right? And I think that's very similar to legal, where you get a reasonable concrete output maybe just by using direct ChatGPT, but sort of those last 10% is so critical to your understanding of what's happening that and you have to sort of already have a mental model of what you think you need to be looking for and how you do due diligence. Similarly.
Yeah, I mean, and this is a conversation I've had over and over. Like the problem is like if you don't know what you're doing, then like it just becomes a complete sort of waste of time because it's going to make mistakes and you're not going to know it's making mistakes. And then you're only going to find out, I mean, at least with coding, right? Like at least you will try to run the app or whatever it is and it will crash or it won't compile, whatever, right? But it's even more dangerous in legal because you don't get that feedback. It's just like now this thing is broken and out in the world, and 5 years from now you get sued, and then you find out the bug that you didn't know about because you didn't really know what you were doing. So definitely agree with all of that, and I think it's the same situation, if not worse, for legal, because you don't have that instant feedback.
Yeah, absolutely. And I think this is, and correct me if I think from a product standpoint and from a technological standpoint, I feel like we really try to provide visibility, not just into the results, but also like to different, like, here's what we think is the summary of the document. Here's how we backtrace the information. We don't expect you to trust us. We expect things to be edited by the user and sort of building in that functionality as well. Because like even the best LLM is going to get it wrong, right? Like this stuff was not trained on due diligence, and I think it would be foolish to sort of expect it to be 100% accurate all the time.
Yeah, I mean, when people ask me, and I mean we're well off topic at this point, but that's cool. I mean, when people ask me, right, like I tell them to sort of, you can think about these things as working with like a junior associate, right? Like they're not going to be perfect all the time. No AI is going to be perfect all the time. You can't just blindly trust it, but it will. If you have a good AI tool, it will get you further than a bad AI tool. But it's never going to get you across the finish line completely. But it makes it easier to get there.
Yeah, absolutely. I think of it as like it gets you further faster, and it helps you build your understanding so much faster. And that's like if I'm in a completely new repository and I just want to understand something, just interacting with Claude Code just gives me such a better understanding of what's going on than just like going through each file myself manually. And I think that same analogy can be applied, but you need to have like a mental map at the end of the day of what's going on, or else it's sort of a hopeless task. If I were to do due diligence with just an AI tool, I think that
it could go wrong.
Lawyers might be in trouble.
It could go wrong. I mean, we won't turn this into a Marveri commercial completely, but I mean, I think the advantage that we give is, the workflows are built for lawyers, And so we sort of know what they are looking for, and we can sort of accelerate their specific workflows. Whereas a chatbot tool, whatever, Claude, OpenAI, they will be useful for some tasks, but the tasks that we build for, I think having that experience built into the product is really helpful. Okay, well, cool. This has been really fun, really educational. I appreciate you doing it. I think we've already given our Marveri plug for the day, although I will just say it's, as I said earlier, Marveri is an AI-powered platform. It helps corporate lawyers basically just quickly figure out large groups of documents. It's really helpful for M&A. It's really helpful for onboarding new clients. I mean, any task that you have to figure out a huge group of documents very quickly. So if anyone's out there and you're interested in learning more, you can go to our website. It's marveri.com, marveri.com. You can read up more about the product. You can sign up for a demo. We're happy to show people the product. So yeah, thanks so much, Emily. And thanks for everyone who's listening to this. If you have feedback for us, feel free to reach out. We're actually going to be doing a lot of content coming up. We're planning a webinar about legal ethics and the use of AI for lawyers. That's going to be really interesting. We get a lot of questions on that from our users. So stay tuned for that. You can follow Marveri on LinkedIn if you're interested in keeping up with those announcements. So yeah, Emily, anything you want to plug? You want to tell people where to find you?
No, that sounds great. You can find me at those same locations.
Awesome. Well, thanks so much, Emily. It's been great.